In the previous section, we estimated the population of the mean of the population. In this section, we'll show how we can use Excel to estimate the population proportion. So, we've got an example here. In previous years, a mail order company observed that 9% of its customers placed additional order within 6 months of the original order. However, from a sample that they've selected, they found that of 1,000 recent customers, there were only 80 customers who placed an additional order within 6 months of their original order. So we want to estimate the population proportion with a 95% confidence interval of customers who placed an additional order. So the 8%, or 80 out of 1,000, is just a point estimate. It's a sample proportion. We want to first check to see if our sample size is large enough to assume a normal distribution, or the approximate of a normal distribution from this binomial distribution. So we take n times our sample proportion, which is 1,000 times 0.08, which is 80. Well, that's greater than 5. And n times 1 minus our sample proportion is equal to 920, and that's much greater than 5. So we can use the central limit theorem in this case. So we first want to calculate our confidence interval, so we need to calculate our standard error of the proportion. Now we did this in section 4. So the standard error of our proportion is our sample proportion times 1 minus our sample proportion divided by n, and then we take our square root. We take that standard error of the proportion times our z-score. Notice that our sample size is large, so our t-distribution is going to be very close, if not exact, to our z-distribution. And we would find that if we sampled the entire population, we would expect that somewhere between 6.3 and 9.7% of the population will come back to a return order. So the fact that we only had 8% in this particular sample doesn't necessarily concern us, because that 9% that we've had in previous years falls within, and so we can say that that difference is really just due to sampling error, not due to something other than sampling error, like poor customer service or something like that. So if the previous observed percentage was 15% instead of 9%, should the company be concerned? Yes, because 15% falls well outside the confidence interval. We can attribute it to something other than just random error or sampling error. And we would say there's something wrong in our customer service or something we're doing within the business. Now, this is how we could calculate this by hand, but there's a way which we can calculate this using the computer. This is an output of the same example. We don't have a data set for a proportion in this case, but we can create one. Now, how do we create one? A proportion is just a dichotomous variable, where 0 represents the absence of something and 1 represents that something has value. And so we find that 80 of our customers return. So we're going to represent 80 as a column of 81s. And then our sample size is 100, or excuse me, 1,000. So I'm going to run this up and represent all those customers that placed an order but did not return with another order within 6 months as a 0. So what I've really done is I've created the data set, and now I can go into my data analysis toolpack, click on descriptive statistics. Column A is my data. In this case, I don't have labels in my first row. I have summary statistics, and I'm going to keep the confidence level for the mean. In this case, it isn't a mean, it's proportion, but we're going to approximate a normal distribution for a mean. And we're going to click OK. Now, what do we find? Here's our error term, so most likelihood error. So if we want to know what the upper confidence level is and the lower confidence level, the upper confidence level is equal to our mean, in this case it's a proportion, so our sample proportion plus our error term, and the mean minus our error term. So we can see that we come up with that value, and we've allowed the computer, Excel, to calculate our confidence interval for us. So once again, to reiterate, we would say we are 95% confident that if we could sample the entire population, we'd expect that population proportion to fall somewhere between 6.3% on the lower end and 9.6%, 9.7% on the upper end for returning customers.